So we've been using the static keyword when declaring variables and methods throughout this course. So it's now time to look at what static actually means and why we used it and why we had to use it in particular places. So what I've done is I've created a new class, as you can see here, and I've actually called the package static using our new naming conventions for packages, which we talked about earlier in this section. So let's go ahead now and create a new class. So we're going to create a new class. I'm going to come down here, as I normally do, down to source. I'm going to right click it, new Java class. We're going to call this static test. Like so. And what we're going to do, it's going to be a public class, and we're going to put a private int, which is going to be num instances. We'll set that equal to 0. Private string name. We're going to create a constructor, and we're going to use the name as the constructor. But what we're also going to do is every time the constructor is used, we're going to type num instances plus plus. So we're going to increment that variable num instances. And then also we need a getter for the two. So we want to put a getter for both num instances and for the name as well, like so. So that's it, very basic class. And so we'll go back now to main and create two instances of the class and print out the value. So we'll go back to there. And so let's start and type static test first instance equals new static test, and we'll call this one, unsurprisingly, first instance. Bit unoriginal. So we'll print it out. We'll go first instance dot get name plus is instance number plus first instance dot get num instances. So, and then we'll do static test second instance equals new static test. It's going to be second instance, and print out second instance dot get name plus is instance number plus second instance dot get num instances. Like so. Now, if we run this, then you probably may have expected each instance to think it was instance number 1, as both have a copy of the number of instances field. So when we increment it to the constructor, it becomes 1 in each case, because of course we started with num instances equals 0. But a static field, which is also known as a class variable, is associated with the class rather than with any particular instance of it. So there's only ever one copy of the variable in memory. All instances of the class share that one class variable. So this means we can get the behavior we originally wanted, where this instance number was incremented every time we instantiated a new object from this class, by coming back here and changing the variable num instances to a static. So we may take a static int num instances equals 0 and not changing any other code. We go back to main and we run that again. You can see now on the screen that we've got num instances number 1 for first instance, and instant number 2 is now for second instance. And just to confirm, we can also create a third one if we wanted to. Third instance. And third instance. Okay, so if we run that now, and we correctly get first instance set to instance number 1, second to second, third to third. So it's still working, as you can see. We've got a single variable with static variable num instances, and only one version of that exists in memory at any time. Now you may or may not have noticed, if you're pretty sharp, that I didn't change this variable here, second instance, yet the program still worked. So why, with me leaving that to second instance when we're calling the third instance, did it still record, or return rather, the correct value? Well, the reason it returned it is because they're all sharing the same copy of num instances, so it doesn't matter which instance of the class we use to access a static field, it's always going to return what is then the valid number. So 1, 2, and 3 again. And likewise, I could have changed that to third instance, which would have been technically correct, and run that And again, we still get the same numbers coming back, and that's because we're still only sharing one copy of that variable with all instances of the class. Now, it's a little bit odd that we can do that, and if you come across code like that, you probably have to stop and think for a while just to make sure it's isn't a bug. It's really bad practice. I mean, leaving that error there is, I think it's really bad practice, and it's not something you'd really want to do. Even though it's perfectly valid, it's much better to use the class name and make it clear that what you're accessing is a static method of field. So in other words, changing this to what should have been third instance. Now, if you're using a method that only works on static fields, it makes far more sense to make that method also static. And that means that we can then access the method without having to use a classed instance to do so at all. So what we're going to do is we'll go back and change the class of the static test class, and we'll change get num instances to static. So we'll put static there. So it's now public static int get num instances, still returning the same variable num instances. But what that means is by doing that, we can go back to our main class, and instead of having this instance name, we can do something like this. We can put static test, static test, static test, like so. And it makes it clear now, because you're seeing that it's the class name, it's not using the instance name in your first instance, that this is a static method. And incidentally, you have used static methods before. When we use the integer.parseInt method from the interfacer challenge, for example, parseInt is a static method of the integer class, and as a result we can use that without having a particular integer to call it from. So just as a recap, static methods and fields belong to the class, not to instances of the class, and as a result can be called by referencing the class name, as you see here, rather than a class instance. And this explains why the main method we've used throughout the course has to be static. This is written on line 5. Because when we want to run a Java program, there has to be an entry point. In other words, a method that's executed when the program runs. However, until the program runs, there's no classed instances to call methods on. So Java has to use a static method that can be called from the class name rather than from a class instance. So that's the reason, again, why the main method is marked as static. So when we run our sample program in IntelliJ, what IntelliJ does is it invokes a Java executable and passes to it the name of the class that contains the public static void main. So provided you've actually built the project, you can run the program from the command line by changing it into the project production directory and then typing something like, from a command line, you could type java com.company.static.main. So Java would then expect main to have a static method called main with the exact signature that we've been using throughout the course. Now the main method doesn't have to be a class called main. It can exist in any of our classes, but the convention is to put it in a class called main. Now if we're given a project containing hundreds of classes to work on, you would at least know where the program starts by looking for the main class rather than having to check every other one to find the main method, and that's why it's sort of a standard convention. So again, this example would be just running it from the command line. We're not going to do that now, but that's how you would invoke it if you wanted to do it from the command line. So now that we understand static methods and fields, and these are sometimes referred to as class methods and class variables, we can work out why all the methods we've created in main have also been static. So what we're going to do is use another example to discuss what's happening and why. So let's go ahead now and change this code. I'm going to comment this code out for now. And let's come down here and we'll put public int multiplier equals 7. Actually, we'll make that a field in this class. So I'll put this at the top, like so. And then we'll create a method called multiply. So public int multiply, and it accepts a parameter of a number and returns the number times the multiplier. So this is a slightly contrived example that doesn't really do anything useful, but what it will do is help you to show what we can and can't do with static methods. So as you can see, the public method multiply takes a number and returns the result of multiplying it with the public multiply field that we defined on line 5. Now we've made multiplier public so that there's no confusion stemming from its visibility. So let's call the method now in main here and see what 6 times 7 is. So we're going to do something like int answer equals multiply 6. And print out a message, the answer. Now in theory that code looks good, but IntelliJ is showing an error, and if we look at that and we'll highlight the error, non-static method multiply int can't be referenced from a static context. And we get a similar error if we try and do something like this. Similar error, non-static field multiplier can't be referenced from a static context. So if multiply is public, then why can't we access it from our main method? Well, as we've seen, normal class fields require an instance of the class. They don't actually exist until an instance has been created. Now the main method is static, as we can see, and it can be called with a class instance. So as a result, Java can't allow a static method to access non-static fields or methods because, frankly, they don't exist when the static method's called. So in many of our examples in earlier lectures, what we did was we created methods for main to call, and in order for that to work, we had to make the method static. And we're going to do that here now so the program can actually work. So the way we would get around that, firstly we would make our variable, our field, static, and also down here, we can make our method static as well. So now that we've done that, we're calling a static method and accessing a static field, everything should work fine. And when we run it, we correctly get the answer 42, and we can see we're now able to access multiply because we've set it as static as well. Now note that the reverse is not true, and there's no reason why it should be. So there's no problem at all with a non-static constructor of the static test class back here. There's no problem with that accessing the static numinstances field, and we can also call static methods from non-static ones with no problems. Now note that there's nothing to prevent a static method from accessing non-static fields and methods in another class because it creates an instance of the class in order to do so. Now the restriction is purely on a static method accessing non-static methods and fields in its own class. So there's one more aspect of static that we need to look at, and that's static initializers. Now the discussion of these also need to consider final fields. So we'll come back to static initializers in the next lecture after we've discussed the final keyword. So we'll see you in that next video.